Oh, Discrete Mathematics, 7.4, Game Theory, second to last section. John von Neumann in the 20s was working with game theory, and he was recognized around 1940, in the early 40s. This is when every player, would have an alternate course of action, which he called a strategy. And what you'd like, certainly, is to select a strategy that would be more favorable to you. Suppose you had a coin match game, and the rules are player 1 wins 3 cents if you get 2 heads, and player 2 wins 2 cents if you have 2 tails, and player 2 will win 1 cent if there's no match. Well, how can you look at this game and maybe get some theory, some strategy to help you play it? Well, this game does not flip the coin. It takes a coin, and you get to turn it yourself and either show a heads or show a tails. If you would use matrices for this, the row part of that matrix would be the perspective. We're going to have, I guess, Tina. Oh, I guess we're going to think Saul is going to play. This is from Saul's perspective. He can either have a heads or a tails. Tina is going to be the columns, which can have a head or a tails. And it is from the rows perspective that these things are going to win. So if Saul is the player 1, if there are heads and heads, 2 heads, Saul wins 3 pennies. If there are 2 tails, that's when Tina wins 2 cents, but that means Saul is a negative 2 cents. This is all from Saul's perspective. And if it's either heads and tails or tails and heads, Tina would win a penny. That means that Saul would lose a penny. So your matrix could look something like that. Now, the question is, what is the best strategy for Saul? Well, hopefully it's obvious, but if it's not, that's fine. We're going to come up with a way of looking at this a little easier. The only really plus in this whole thing is for Saul is this heads. So if Saul's going to show a coin, then he should always show a heads. And what is the strategy for Tina? Should Tina ever show a heads? No. Although one situation here for Tina is in her favor. Remember, the negatives are really for Tina. Showing a heads would be possible that Saul would show a tails. Probably wouldn't. And so if he's always going to show a heads, then you would always like to show a tails if you're Tina. And you might say, gosh, this is getting confusing. And it's only 2 little things that you're doing. So how do you look at this? Well, if you take a view from these, then you can say, okay, let's look at the rows and look at all the minimum values for each row. In this first row, -1 is that minimum value. In the second row, a -2 is the minimum value. Now let's take a look at each column and look at the maximums. So the maximum for this column is 3, and the maximum for this column, remember we're talking negatives, so a -1 is the maximum for that column. Okay. And now, to sort of gather these together, because we're doing this from Saul's perspective, we would like in a sense, the maximum of the minimums. So the maximum of the minimum is really the -1. And for Saul, that would be, I guess, the least he could lose, so to speak, is a -1. The maximums for the columns, you would want the minimums for that because that's for Tina. So he would give up this. So this is called the maxi-min, because it's the maximum of the minimums. And this is called the mini-max, because that's the minimum of these maximums. And if they are the same, and they are both -1, that -1 is called the saddle point. And if the saddle point for each of these, the maxi-min and the mini-max, is the same, then this is called a strictly determined game. What does strictly determined mean? Well, use the same strategy every time. For each play, so to speak. So you know what to do every single time. For Saul, he should always choose heads. Remember, you get to choose, you don't flip it. And for Tina, she should always choose tails. And from Saul's perspective, if he's forced to play this game, that's the best way to go, because there's no way that Tina's going to choose heads. So, if Saul chooses tails for some reason, then he loses twice as much here. So the least amount that he'll lose is this -1. And then, because Saul will always choose heads and Tina will always choose tails, then the most that Tina can win is 1, and the most he'll lose then each time for Saul is that 1. So strictly determined. This is not a very good game for Saul, and it is not fair because the saddle point is not 0. Because this is either positive or negative, and it doesn't matter which. Somebody's got an advantage. It's not a fair game. Well, let's try another one of these just to see if we can come up with something maybe a little different. Suppose Linda has talked to you and said, I hear you know game theory, and I want you to be my consultant in this game I'm playing. It's called Two-Finger Mora. So what you do is you hold your fist out, and there's 2 players. Each of one either holds out 1 finger or 2 fingers. And this is from a closed fist. So if the sum of the fingers is 2, I'll give you $5, Linda says. And if it is 4, you give me $5. And if it's odd, then it is a draw. So this is from Linda's perspective. And so Linda can either have 1 finger or 2 fingers. And whatever the opponent is here can either do 1 finger or 2 fingers. So, if Linda, once again, Linda says, if the sum of the fingers is 2, then Linda gets $5. And if the sum is 4, then Linda loses 5. She'll pay whoever the opponent is. And if it's 3, 1 and 2, or 2 and 1, then nobody wins. It's a draw. So Linda's asking you, as you're being the consultant, what should the strategy be for this situation? Well, let's see. Remember, we'll look at the minimums. Let me stick with the same color scheme. What are the minimums for the rows? Well, the minimum here is 0, and the minimum here is a -5. And what are the maximums for the columns? The maximum is 5, And the maximum is 0, because a negative 5 would be worse. Okay, and now you want to know what is the maxi min. The biggest min here is this. And what is the minimax? The smallest maximum is this. So for Linda, she should always choose one finger, because that would be the worst situation to have a push. And the opponent, if they were smart and set up one of these, they should always use 2 fingers. So they would be a push all the time, because then it would always be this 3. Does this make sense? So the best strategy is just show 1 finger. For the opponent, the best strategy is to show 2 fingers. Now, since this payoff, this saddle point, is 0, then this is a fair game. A fair game is when the value of the game is 0. Here, the value of the game is that -1.